Good day. So now I'm going to discuss resistance. So we have covered capacitance previously, both the geometric approach of finding its value and utilizing the formula that contains voltage and charges, which are very crucial in series and parallel connections. Okay, so now we're going to learn the use of resistance. Okay, so the values of resistors in a circuit in terms of the material being used, and of course its geometry, then at the same time its application on circuitry in general. So here are the objectives that we want to achieve. So we have to define current, voltage, and resistance. Of course, we have defined voltage already, current in a way. Okay, and then understand how resistance can be obtained from area and length, and then lastly, of course, understand Ohm's law and be able to solve problems involving both. Alright, so resistance is the ability of the material to oppose the current. Okay, so if you're going to draw a circuit, okay, so resistance is like this, or represented by this. So if this is your current, okay, so the resistance put a certain way of slowing it down, or regulating it. Okay, so you can say na the value that will pass will be regulated in a way. Okay, so this is the purpose of the resistance. So it avoids overvolting, okay, and then among others, right? Then the material that is being used has an intrinsic property called resistivity. So this is a constant. Okay, so it's an amount of resistance a material can withhold, which depends on the material's composition and structure. So hence the geometric approach. Okay, so these are the factors that affect the resistance of a material. So we have its length and then its area. So knowing those, you can understand now the formula, which is this. Okay, so resistance is defined as the resistivity constant multiplied by the length divided by the cross-sectional area of the material. So if you're going to have, let's say, a resistor that looks like this, say it's being chopped. Okay, so let's say it has been chopped. Okay, so this, and of course these are the lengths. Then you have the cross-sectional area, which is this. Okay, then of course the material itself is the resistivity constant. Okay, so try to remember that we're going to utilize this equation later on. Alright, so here are the constant. We're going to return to them. What's important here are the resistivity constant, so don't mind the temperature coefficient. Okay, so there you go. And then let's have a revisiting on the definition of voltage. So this is the amount of energy required to move a charge, right? So if you still remember, we already have the geometric approach for resistance, right, which is rho L over A. Now we have voltage, sorry, which is defined as the amount of energy required to move a single charge, okay, or EPE or E sub PE. Okay, so electric potential energy, divided by charge. Okay, so for current, okay, so current is signified by letter I, okay, is defined as the flow of charge. Okay, can also be stated as the net flow of charges passing in a circuit per unit of time. So that means our formula for current is Q over T. Okay, then lastly, of course, we have Ohm's law. So defining resistance utilizing Ohm's law will be R is equal to V over I, or in this case V is equal to IR. So here you go. So connecting these three, you can utilize how to define resistance in terms of the other variables. So you can define resistance in terms of PE over Q multiplied by, so this is divided by I, so we're going to reciprocate, so this will become P over Q. Okay, which can be rewritten as PE times time divided by, well, you can write it as QQ. Alright, so, or Q squared. Okay, so that's one of the ways of defining it. And then energy over time is what? Work over time, so that can be power over Q squared. You got that? Okay, no, this is work over time. Oh, that doesn't, there's no what do you call this? We haven't learned any variable yet that describes potential energy multiplied by time. Anyway, something might come up later on or in the future, but for now it will remain something like this. Okay, so there you go. So for this part, resistors and color bands, I think this is better to be discussed by your teachers. Alright, so I will be leaving this to them, and then of course to have some exercise